Hi, I'm Séan Brady. I'm curator of bees and chair of entomology here at the National Museum of Natural History. I'm going to talk to you for a few minutes today about our digitization efforts on bumblebees. And this first set of slides were generated by Patricia Kinsley-Poole, who's right over there, and she's in charge of our digitization efforts in general in our department. So I just want to kind of let you know kind of how the stuff that you're going to see in your computers today, how that ended up getting there. What was the general process? So we have a huge collection here at the museum. We have actually over 30 million specimens just within entomology alone. In terms of our pin collection, we have about 19 million insects on pins, meaning that they're in drawers like this with pins stuck through them, sitting, most of them, right upstairs above you. And what we're trying to do is enhance the value of these collections. For someone to come to study the bees in this drawer, they have to physically come visit the museum, try to read these labels, and it's not a very useful format for these data. So what we're trying to do is take these 19 million pin insights and at least get the information contained about where they were collected up available, digitized on the web so that the whole world can use our information. This is quite a big challenge, and this emphasizes the fact that the information just on these little labels, handwritten often, sitting in a drawer upstairs, is not very useful to the scientific community. So in order to get these data digitized, there's three basic processes. First, we have to get the specimen prepared in order to be digitized. And then we take images of the information that's on the labels. And then the third step, which is what you're helping with today, is processing the image data into a format that we can get into a database. And so what Patricia oversaw last summer was for 8 weeks, her and a whole kind of small army of interns, they went through the collection. They first added some barcode labels so that they can keep track of all the information throughout the whole process. Then they had to take the specimens and the labels, each individual one, off of the pin, very carefully of course, stage them, put them in a way that they can then image them under this camera. And then the camera took images of the labels and the specimens, and that's what you'll see in your computer today. But then, of course, after that was done, then they had to carefully replace the labels and reassemble all the specimens and put them back into the collection. And then they kind of imaged quality, cropping, and got the images ready for you to work with today. Now, why bumblebees? Why is it important to digitize bumblebees specifically? So there's about 250 species of bumblebees around the world. And that might seem like a lot, but actually there's over 20,000 species of bees in the world. So there's a tiny fraction of overall bee diversity. However, they are very kind of large and furry. They're very commonly encountered in people's gardens. Here's an example of bumblebees of the eastern United States. And they're all familiar to everyone here. Now, bumblebees are unusual for bees in that they are primarily found in kind of colder climates. Most bees are found in kind of deserts or tropical areas. So here's a map of bumblebee diversity. Red is the most diversity, and blue is the least diversity. This is a heat map. And you can see that the centers of diversity from bumblebees are in places like around the Himalayan mountains, and here up in the Alps. Even here in North America, there's more bees in the western United States, say along the Rockies, than other regions. Very little diversity of bumblebees in South America, none in the African tropics. In fact, that's why they're so big and so hairy, is that enables them to generate enough heat and retain heat so that they can live in these cooler environments. Now, I said that bumblebees are really just a fraction of bee diversity, but they're very important pollinators for several reasons. And the first reason is that they can do what's called buzz pollination, which is unlike other bees, including honeybees. And that is when they land on a flower, they sonicate the flower. They vibrate intensively, and it dislodges the pollen from the flower. And what this does is, first, it allows the bee to collect more pollen, of course. But some flowers actually require this type of buzz pollination in order for effective pollination. So crops like blueberry and tomato are much more effectively pollinated by bumblebees than any other kind of bee, including honeybees. And here's a picture of a bumblebee, and you can see here, this thing here is a big wad of pollen that's been kind of stuck onto its leg. So they're very efficient pollinators because they can store a lot of pollen on their bodies. And what they do is they bring this pollen back to their nest. Now, bumblebees are interesting because, first of all, they're not like honeybees. So most people think of a bee and they think of a honeybee with big colonies of thousands of workers in a hive that live kind of year after year after year in the same place. So they're not quite like that, but also not quite like most other bees that are actually solitary. So most people don't know that most bee species don't live in colonies or hives, but actually just live lives on their own by themselves, just like most other insects, like a fly or a beetle would. Bumblebees are kind of in the middle. We call them primitively social, so they do form nests. They're often very small, only tens to hundreds of workers in the nest. And their nests are annual. In other words, the queen will start a nest in the spring. It'll go through the summer, and then she'll mate at the end of the summer, and she'll basically hibernate. But the old queen will die in the winter, and the new queen will start a brand new colony every year. Now, bumblebees are very important pollinators, but as we study bumblebee populations, we're increasingly finding that, at least for some species, they're rapidly on the decline. And this is where the importance of your efforts today fall in, because the only way we can really know if a bumblebee species is declining is, first of all, to know, say, 50 years ago there were bumblebees in a particular spot, and they're not here anymore. The only way to get that kind of historical information, what was living 50 years ago, is through museum collections such as ours. So what scientists have been doing is using digitized collections to create maps where, in this case here, the purple circles are historical records from 1884 to 1999, and then these triangles are collections today. So you can see for this one species, a bumblebee, historically it was found across most of the eastern United States, but recently it's only been collected in kind of certain areas, and it appears to be absent from some of these areas where it was once fairly common, say 50 years ago. And the only way we can get this kind of information and infer that species like this are on the decline is from using museum collections and getting that information digitized so that scientists can create maps like this in order to study the historical demography of these bees. Our bumblebees so far have not been digitized, so the bumblebees you're going to be working with today that are in our collection could not go into this map. So you're going to help to solve that impediment today by digitizing the bumblebees in our collection. We have over 40,000 specimens of bumblebees from about 200 species. And so our goal is to digitize all those 40,000 specimens so they can be used for this type of research. So that's all I have to say.
Thank you, John.
Sure.
Thank you.